Ja. Så dere får dessverre ikke høre på den flotte sørlandsdialekta mi I 7 minutter nå, for vi skal kjøre denne på engelsk. So, hello everybody, I'm Erfan Mohammadi and the head of cloud infrastructure at Intility. And I have the pleasure today of sharing with you some insights from our recent process of fortifying the data defenses for more than 600 Scandinavian companies on the Intility platform. So we'll go through some concepts of backup immutability, how we've built a dark site, and towards the end we'll cover some playbooks for ransomware recovery as well. But first, just briefly about Intility. So if you were trying to put a label on what we do, we would typically fall under the category of a managed service provider, but not really in the traditional IT outsourcing sense. What we've been doing for the last 20-some years is to build an industrialized and standardized IT platform service where we invite companies to migrate onto this platform as a true multi-tenant community platform. And it's end-to-end and has really given us an opportunity to give a degree of security, automation, and scalability that's hard to or challenging to replicate in other delivery models. So this service is being used by more than 650 companies across 2,500 locations worldwide, many of whom are critical to societal functions as well. And the backup architecture that I'm going to talk about today is built on our own cloud service, which we produce here in Norway. So it's a sovereign cloud multi-tenant platform. Although we're managing also a lot of workloads in the public clouds, and some of the principles I'm talking about here would apply there as well. All right, so to kick things off, this is a timeline of the second half of 2023. Some cases, among many, where we see organizations being attacked, not only on their production data, but on their backup infrastructure as well. So the threat of ransomware attacks has been around for quite some time now, but what we observe in the recent years is that the attack on the backup systems and the backup infrastructure as well have increased. And this can often lead to catastrophic outcomes because if you lose both of your production and backup copies, you've virtually lost all of your data, and a lot of organizations, unfortunately, can't recover from that. So to meet these changes in the threat landscape, as well as extensive functional requirements we have for our multi-tenant platform, we started a process about 3 years ago on assessing new backup partnerships. And these were some of the main criteria we were looking for. And when all was said and done, Cohesity came out as the preferred partner. It especially had to do with their extensive security features, the scalability and performance of the system. And one of the key things we were looking to introduce into our offering was backup immutability. So we'll start there and have a look at a quite straightforward definition of backup immutability. But I want to turn your attention to the words in cursive here. So the after entails one important aspect, and that's that immutability doesn't protect you from the occurrence of ransomware attacks. So if anything is encrypted in production, it will find its way to the backup as well. And the other thing to note here is that I've highlighted the backup system. So immutability operates within the sphere of the backup system or the backup software. It doesn't say anything about the risks to the underlying hardware. And I'll get to that when we talk about the dark site design. Another important thing to note is that backup copies aren't typically immutable forever, so they follow the same kind of retention policies and automated deletion methods within the backup system. So although it's a great thing for data protection, there are some challenges that might arise as well. And these challenges are quite ironic in their nature and has to do with the selective deletion of data. So one of the most prominent challenges has to do with GDPR regulations. So in GDPR, we have Article 32, has to do with the confidentiality, integrity, and availability of data. And in those terms, immutability is a great technology, especially when it comes to the data integrity part. But then we have Article 17. It addresses the right to erasure or the right to be forgotten. And I know this is kind of a controversy, especially in the backup world. Anybody that has worked with backups know how much of a hassle it would be to kind of restore tens or even hundreds of backup restore points, delete that data, and then archive it onto a secondary storage platform. So to this day, I haven't seen a single organization doing this. And immutability actually only adds to this challenge. Now we even don't have the possibility to delete that data. So this right to be forgotten is without undue delay. And what does undue delay mean? It's typically set to 30 days per GDPR guidelines. And what we've done with this is we've limited those immutable policies, not applying them to the yearly backups and setting a limit upwards of 6 months for those kind of copies. And then we ask ourselves this question, well, we got this great technology with immutability, but is it enough? And when our cloud engineers and security architects got to work at the issue at hand, we quickly realized that we should aim for some additional security measures. And that's ultimately resulted in the dark site design. As I said, immutability operates within the backup software sphere. It doesn't say anything about the underlying hardware. So when we were building the dark site, one of our foremost concerns had to do with remote access. So as probably a lot of you know, when we're managing our cloud services, our data centers, we're doing so remotely in order to be efficient. But those remote accesses can have vulnerabilities, and an attacker might use them to, let's say, run a disk partitioning on the underlying storage hardware, which might compromise the data. So we quickly realized that we should remove this remote access, so that's what we did. Now we have to physically go out to the data center to perform those management tasks that we would otherwise have done remotely. And then when it comes to the actual physical access control, we specifically chose a data center which has extensive multi-layered security features, including biometrics, and we'll have a look in a second at that data center. And this also kind of went into our risk-based approach that we have to data center security with third-party audit activities. When it came to minimizing the attack vectors, this was all about kind of minimizing the equipment there. So we didn't fall for the temptation of offering other cloud services from that data center, although we kind of went into another region. So it exclusively hosts the backup hardware as well as essential networking equipment, and thereby minimizing the attack vectors on that site. Next, with Cohesity, we got a really great role-based access control. And this makes it possible for our support technicians, our incident responders, to perform simple backup tasks such as restores, but limiting those administrative rights to the backup system to only a handful of people at Intility. And when they access the backup systems, they have to do so from a physically hardened client that has its internet access shut off. And the last major category here had to do with minimizing the allowed traffic. So that there is an active link to this dark site. We're replicating tens of terabytes each day, each hour, depending on the policy. So it was important for us to secure that network connection, doing so by a dedicated dark fiber connection in transit encrypted, and making sure that it's only allowed to communicate with the central backup platform. So with all of these kind of mechanisms in place for building the dark site, and for obvious reasons I can't go into too much detail on how this is set up, but I still often get the question whether or not this site is air-gapped. And the short and honest answer to that is no. So air-gapped rests on a definitive premise, which is basically that it's isolated from the outside world. And a lot of vendors are kind of throwing this term around. From our standpoint, we, as I said, are replicating data on an hourly or daily basis to this dark site in order to have a low RPO. And in the more kind of traditional approaches to building the air-gapped solutions, one would often resort to tape backups. And then you're dependent on physically swapping out those tapes. So you would typically get an RPO ranging from weeks or months in many environments. And that more manual approach is often also more costly, less efficient, but I should point out ultimately more secure. But for us, when we were building this, the kind of combination here of the immutability and dark-side really went into an already established multi-layered defense we have, ranging on everything from compute and storage with geo-redundancy and failover capabilities to what we do on the data center physical security side, and then an extensive portfolio of software and people at Intility protecting all customers in this community model. So with this approach, we believe we've moved as close as we can to an air-gap solution, reducing the risks significantly and not compromising on functionality. So this is kind of a bird's eye view of how this is set up. Our main region in Oslo with geographically distributed data centers with storage replication and full DR capabilities. We're applying a backup level immutability using S3 Worm with the Cohesity technology, replicating it each day to this dark site. Now this data center is quite exciting. It's a former NATO ammunitions facility that was repurposed to a data center some years ago. So it has things like natural EMP protection through 100 meters of granite rock and was in its time built to be able to sustain nuclear attacks. And going back to the Intility platform model and the one-to-many kind of standardized architecture and delivery model that we have, we were able to implement this backup architecture across more than 600 Scandinavian organizations. It wasn't done overnight. We're talking a lot of petabytes of data that had to be moved into this architecture, but it kind of showcases how this delivery model can make large investments like this and protect a lot of companies in the community model. All right. So to recap what we've talked about so far before ending my presentation with ransomware recovery, really we can look at 3 attack vectors and their remediations. So I should point out that if you're concerned about the single workload or a single system, the kind of traditional backups could protect you from that. You would restore to, let's say, a healthy version. But as we saw in the introduction, more and more organizations are facing attacks on their backup infrastructure as well, and that's where immutability comes in. And lastly, even though we haven't seen widespread use of this attack method, keep in mind that there can be some underlying risks or some risks to the underlying hardware as well. And that's why we decided to build the dark site on behalf of our customers. All right, so to round off my presentation, I'm going to share one slide on the framework we use with our customers to address questions on business continuity, attack scenarios, and disaster recovery exercises when it comes to ransomware. And I apologize in advance because it's a quite busy slide, but I'll be happy to kind of discuss it in detail afterwards. So what we're looking at here is that single service or multiple services are being compromised with a timed attack. And we're drawing out a timeline here. And I've also included our kind of standard backup policies in the top left corner there. We'll get to that in a second when we're looking at the RPOs, the recovery point objective. So how long, or I should say, what point in time restore can I perform? So the first red line here is the actual ransomware infection. But with the timed attack, keep in mind that there can be a time difference between when the system was infected and the ransomware attack was initiated. And this is typically where the attacker will do their triaging of the environment, and we have a so-called dormant infection. From there, we actually have to discover the ransomware attack as well. Cohesity has a great technology for this. They use an AI engine which looks for anomalies in the data ingest patterns between different backup runs, which could be a great indicator of an ongoing ransomware attack. So after we've discovered the attack, on the right-hand side of these red lines, we have the RTO, the recovery time objective. So how long does it take before we're operational again? So I'm going to draw out some activities here, and they might differ in different kind of environments, but to kind of paint some broader categories. The first thing, well, somebody has to respond to this. We have an upwards SLA of 45 minutes on security incidents at Intility, so that's something to keep in mind. Our incident responders would typically have one of the first things they will do is to isolate the servers, services, or users. That can be, in most cases, performed quite quickly. And then we will start the work of our triaging to try to find the attack vector and start time. But this can be a quite time-consuming endeavor, depending on the scope of the attack. So in parallel, our backup technician, application teams, DBAs, would start to restore arbitrary restore points into a sandbox environment in order to try to find a healthy restore point. Of course, we don't want to kind of reintroduce an unhealthy environment back into production. I'll get back to these X and Y's when we look at the formula for calculating the time at the end. All right. From here, the customer basically has two options. We have route 1 on the top-hand side here. That's the more simple approach. You restore your systems from backup. So you have a healthy restore point. It can be more challenging with time attacks, I should say. But let's say you have it. You would restore from backup, and then you need to know how fast you can do that. Right? With Cohesity, we have a great technology with mass restore and highly performant systems, so it can be done very efficiently. Now, the more tedious route here is to provision the servers from scratch and setting up the system from scratch. Now, this route comes into play either if we don't have a healthy restore point, we don't confidently have one. So, and the other thing is if the company cannot or will not accept the data loss. The data loss could be weeks, could be months. So that ultimately that's up to the customer. Now, in this more tedious route, we would provision new servers. That's done fairly quickly. But kind of a thought provoker I see with many customers is that once they kind of start to drill down into their third-party application vendors, internal teams for setting up the systems and what kind of response times they have, that can vary quite a lot between different environments and applications. Typically, we would integrate some of the data into the newly provisioned systems. So databases could use a fresh backup. In most cases, the databases in themselves aren't encrypted. And then we would proceed to restore those. All right. So all of this results in some quite complex formulas. It has some X and Y's and Z's, which kind of showcases that it's not very easy to answer a question on how long it takes to recover from a ransomware attack. But what we see is going through these exercises, either as tabletop exercises or on some test systems, can give a great insight into the time one would typically spend, as well as kind of organizational things such as decision times and stakeholders at those companies. So, thank you for that.